right, so here's the review. It says graph and find the following information for the given function. So y equals x squared plus 3. Since x is directly squared, we're going to call that standard form. So axis symmetry, x equals opposite of b over 2a. There is no b value, so we can see that a is 1 and c is 3. So 0 over 2 times 1, so 0 divided by 2. So therefore, x equals 0. You can also place that 0 for the x value of the vertex. And from here, to get our y value, we plug it into the function. 0 squared plus 3, which is just 3. So our vertex is 0, 3. Direction, since a is positive, it's positive 1, it's opening up, so that's going to give us a minimum. And our min value is the y value of the vertex, so 3. Roots, we'll get this from graphing it. So our vertex goes in the middle, 0, 1, 2, negative 1, negative 2, so that is 3. So 0, 1, 2, 3. Here you can plug 1 into the equation. So parentheses 1, close parentheses squared, plus 3 is 4. And now we're going to plug in the 2, parentheses 2 squared, plus 3, oops, is 7. And then since this is the vertex, we can reflect them over. So this would be 4, and this would be 7. So now I make my point. So, oh, sorry, 0, 3 is up here. So 1, 4, and 2, 5, 6, 7. And we'll reflect that. And we'll make our graph. And here we'll see that it does not cross the x-axis. So the roots, there is no solution. And last, standard form. Well, this equation is already in standard form, so y equals x squared plus 3. All right, on to number 2. All right, so number 2 is vertex form. You guys see parentheses squared, so that means this is h and that's going to be k. So let's go ahead and circle vertex form. Axis of symmetry for vertex form is x equals h. So in this case, opposite of negative 2, so x equals positive 2. For our vertex, h comma k, so let's kind of put this. This is a, h, and k. So the opposite of negative 2 is 2, comma k stays the way it is, so 2, comma 1. For our direction, it is facing down. A is negative, so it's facing down. That's going to be a maximum. And it's the y value of the vertex, so it's y equals 1. And for our roots, we will do that in a sec here. So let's go ahead and graph this here. So 2, 1 in the middle. 2 numbers bigger, 3, 4, consecutive order, 1, 0. So 2 and 1. Now this time, instead of plugging numbers in, I'm going to use the 1, 3, 5, 7. And I see the a value is negative 1. So if I multiply this by negative 1, each one becomes negative down. So from here, I go right 1, down 1, right 1, down 1, 2, 3, right 1, down 1, 2, 3, 4, 5. And that's all I can fit on there. So left 1, down 1, left 1, 1, 2, 3, left 1, 1, 2, 3, 4, 5. Make my graph. And fill in my table here. So these are zeros. And this goes to negative 3. So here I can see my roots where they cross the x-axis. Also here where y is equal to 0. So 1, 0. And 3, 0. Standard form, I'm going to have to FOIL this out. So we're going to start with this equation, negative parentheses x minus 2 squared. We're going to write that twice. Plus 1. So negative, we're going to FOIL this. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Close your parentheses. Don't forget bring down your plus 1. Negative x squared. These combine to negative 4x plus 4. Close parentheses plus 1. we distribute our negative, bring down our +1, and last we can see we can combine those two. So y equals negative x squared plus 4x, and negative 4 plus 1 is negative 3. All right, next one. Another thing we could ask, honestly, is like the y-intercept. So here we see this is 0, negative 3. Y-intercept here is 0, 3. Let's take a look at 3. 3 is another problem in vertex form because it's parentheses squared. So first, we'll circle vertex. Axis symmetry, x equals h. So x equals opposite of that is negative 1. For our vertex, h comma k, so the opposite of that, negative 1 comma 4. Direction, it is facing up because a is positive. So that's going to be a min, and the min value is 4. For my roots, I'm going to go ahead and plug this into the graph here now. So let's see. We can use this color here. All right, so negative 1, 4. So numbers are getting bigger. 0, 1, smaller. Negative 2, negative 3. And once again, you can do 1, 3, 5, 7, but in case you're going to use a calculator, let's go ahead and show that again. All right, so we plug in zeros. So 2 parentheses 0 plus 1 close parentheses squared plus 4. And we get 6. And then now we plug in the 1. 2 parentheses 1 plus 1 close parentheses squared plus 4, and we get 12. And reflect those. Oops, that should be a 6. And 12. Now we make our graph. So negative 1, 4. Negative 2, 6. And after that, they go off the graph. So 0, 6. Looks something like that. All right, so in terms of roots, I have no solution because this does not cross or touch the x-axis. Standard form, just like the previous one, we are going to FOIL it out. So 2 parentheses x plus 1 times x plus 1 plus 4. Distribute our x. X times x is x squared. X times 1 is 1x, 1 times x is 1x, and 1 times 1 is 1. Combine our like terms inside the parentheses, so 1x plus 1x is 2x. Don't forget our plus 4. Distribute the 2 now. So 2x squared plus 4x plus 2. And don't forget our plus 4. So y equals, I can combine only these two. 2x squared plus 4x plus 6. All right, on to the next page. All right, for number 4 through 7, same directions. So this x is directly squared, so I know that is standard form. Axis symmetry, x equals, this is a, b, c, so the opposite of b over 2 times a. So negative 2 divided by 2 is negative 1, so x equals negative 1. Let's go ahead and plug negative 1 in for the x value of the vertex. Now we're going to work it out. So negative 1 in parentheses squared plus 2 times negative 1 plus 4. So let's make sure we don't make any errors, just parentheses, negative 1 close parentheses squared plus 2 parentheses negative 1 plus 4, so 3. So the y value of the vertex is 3. Graph is facing up because a is positive, so that's a min. The min value is the y value, which is 3. For our zeros, let's go ahead and put this in the graph. Negative 1, 0, 1, negative 2, negative 3. Here I will use the 1, 3, 5, 7. So let's write it right here, 1, 3, 5, 7. And since a is 1, I don't have to multiply those by anything. So let's do 1, 3. So negative 1, 1, 2, 3. And right 1, up 1, right 1, up 1, 2, 3. Same over here. And it's going to make these points now. So 0, 4, 5, 6, 1, 7. Reflect them. There it is. Once again, does not cross the x-axis, so no solution. And for here, the y-intercept, you could plug in 0 for x. So two ways you could do this. So if you plugged in 0, so y equals 0 squared plus 2 times 0 plus 4, we get 4. Also, the formula is 0, comma c. So this one would be 0, comma 4. And make sure you do write this as an ordered pair. All right, number 5, it's another standard form one. All right, so axis is symmetry, x equals a, b, c, opposite of b over 2 times a, which is 3. Vertex, 3, comma, so we're going to plug 3 into here, so 3 in parentheses squared, minus 6 times 3, plus 5. Type it in the calculator. So we have parentheses 3, close parentheses squared, minus 6 parentheses 3, plus 5. Enter, and we get negative 4. So negative 4. All right. That is going to be facing up, so it is a minimum, and the minimum value is negative 4. For my zeros, let's go ahead and put this in the graph. So 3, 4, 5, smaller, 2, 1, and it's negative 4. So let's plot that point. 1, 2, 3, 1, 2, 3, 4. Here, once again, I'm going to use 1, 3, 5, 7. And my a value is 1, so I don't have to change those numbers. So right 1 up 1, right 1 up 1, 2, 3, right 1 up 1, 2, 3, 4, 5. And do the same thing over here. Yep, right there. All right, so this is 4, negative 3, and 5, 0, negative 3, 0. So for my zeros, I see they cross at 1, 0, and 5, 0, or I can see that from the table. Y-intercept, once again, is 0, comma c, or plug in 0 for x. So 0, comma 5. And from here, we can see it does intersect at 5. All right, on to number 6. 6, I can see there are 2 x's, so that's automatically going to be intercept form. So the first thing I should do is find my intercepts. So we'll call this A, P, and Q. So the opposite of x minus 1 is 1. So 1, comma 0. Opposite of 3 is negative 3, so negative 3, comma 0. So there's my intercepts. I can see a value is positive. So I know it's going to be a minimum. And now I'll get my axis of symmetry and my vertex to find the minimum value. Okay, so axis of symmetry. X equals P plus Q divided by 2. So it doesn't really matter which one's P, which one's Q. So 1 plus negative 3, or 1 minus 3, divided by 2. Negative 2 divided by 2 is negative 1. So X equals negative 1. Negative 1, comma. Now we plug this into our equation. So 2 parentheses negative 1 minus 1, parentheses negative 1 plus 3. Type it in our calculator so we don't make errors. Where are we at? And we get negative 8. So minimum value is y value, which is negative 8. Last, we convert it to standard form. Whew. So 2 parentheses x minus 1 times x plus 3. So we're going to FOIL this out, bring down our 2. X squared plus 3x, distribute our negative 1, combine our like terms, and then last we distribute our 2. Oh, minus 6. All right, and I also probably should graph this. So negative 1, negative 8, bigger number 0, 1, smaller negative 2, negative 3. So let's plot negative 1, 5, 6, 7, 8. And we'll use the 1, 3, 5, 7. But our a value is 2, so we multiply these by 2. So this is 2, 6, 10, 14. So we go right 1 up 2, right 1 up 6, which gives us our root right there, and right 1 up 10, we can make those, left 1 up 2, left 1 up 6, and left 1 up 10. So there we can see our graph. And we can see it intercepts at 1, 0, and 3, 0, and negative 3, 0, which are our roots. And 0, comma, looks like negative 6, and negative 6. All right, number 7, once again, is also intercept form. So get my roots first. Intercepts are, opposite of that is, let's write this A, P, Q. Opposite of positive 2 is negative 2, so negative 2, comma 0. Opposite of 4 is negative 4, comma 0. Axis symmetry, P plus Q divided by 2. All right, so X equals negative 3. Vertex, negative 3, comma. Let's go ahead and plug this into here. So negative 2, parentheses, negative 3 plus 2, negative 3 plus 4. Let's type it in our calculator. Right here, so negative 2, parentheses, negative 3 plus 4. And we get 2. All right, so put that in the middle. Bigger numbers, smaller numbers. All right, it is facing down because A is negative, so that's going to be a maximum, and the Y value is 2. To make our graph, let's go ahead and negative 3, 1, 2, 3, and up 2. And here we'll just plug the numbers in, get a little practice if you're going to try it that way. So let's go ahead and plug negative 2 into this equation. So negative 2, parentheses, oops, negative 2 plus 2, and then parentheses, negative 2 plus 4. And we get 0. Do the next one, negative 2, parentheses, negative 1 plus 2, negative 1 plus 4, and we get negative 6. And over here, we knew our roots were at negative 2, 0, and negative 4, 0. And then we have negative 1, negative 6, and negative 5, negative 6. Make our graph. And there we go. All right, for standard form, FOIL it out. So negative 2, parentheses, x plus 2, x plus 4. Bring down the negative 2. X times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 4 is 8. Negative 2, x squared plus 6x plus 8. Distribute the negative 2. So y equals negative 2x squared minus 12x minus 16. All right, number 8. What are all the names we give for x-intercepts? We have roots, zeros, and solutions, as well as x-intercepts. All right, use the following graphs, write the equation in intercept format. Here we go. So this is intercept format right here. So I need to define A, P, and Q. So for A, we go right 1, and then we see it goes up 1, 2, 3, 4, 5. It's at 6 right there. So A is 6. P and Q are my roots, so I have one at 2, and I have one at 3, 4. So now I just plug these 3 numbers into here, so y equals, A is 6, parentheses x minus P is 2, parentheses x minus Q is 4, and there's my equation. All right, number 10, starting from the vertex, write 1, down 1, so I see A is negative 1. P are my roots, so we have 1 here and 1 here. So we have negative 2, negative 5, negative 6, negative 7, and negative 8. So starting with y equals, A is negative 1, so just a negative. X minus, when I plug in P, becomes positive 2 because it switches the sign. X minus, negative 8 plugged in here becomes positive 8. All right, and make sure you are able to do this off tables as well. Number 11 and 12. So for this one, it wants us to find the vertex format. So A, H, and K. So for A, we pick the vertex. The vertex is right here. And the coordinates are -1, -2, -3, and -6. So -3, comma, -6. A value is right 1, up 1. So that's just 1. So now we plug it into the equation. Y equals A. We don't need to put 1. Parentheses x minus. When you plug in -3, becomes +3 squared. And then K is just -6. All right, and for number 12, once again, find the vertex. So we see the vertex is right there, so we just add 6, 5, 6, 7, so 6, comma 7. A value, start here, go right 1, down 2, so -2. Now we plug it into the equation. Y equals, A is -2, parentheses x minus 6, squared, +7. All right, next page. So 13, 14, and 15 asked to write the transformations. So it's a vertical compression by 1/3, right 2, down 1. Vertical stretch by 2, left 1, up 4. And this one reflects across the x-axis, right 2. All right, number 16. The path of a ski jumper after takeoff can be modeled by this function here, where x is the horizontal distance in feet and y is the height in feet. All right, so first thing we have to do, when we looked at the form, we have to figure out, is it standard, vertex, or intercept? So remember, standard is x directly squared, which is not happening here. Vertex is parentheses squared, but we do have parentheses, but it's not squared, so it's not vertex. And then intercept has 2 x's, so we do have 2 x's right there. Okay, so x-intercept. So if there's 2 x's in its intercept form, then my intercepts are x equals 0 and x equals 46. Axis of symmetry, x equals p plus q divided by 2. So x equals 23. Now we plug 23 into our equation here to get y. So -0.00, oh, 10. -0.023 parentheses 23 close parentheses 23 minus 46. All right, and from here I'm just going to type it in my calculator. So -0.023 parentheses 23 close parentheses 23 minus 46, and I get 12.167. All right, so how far did the skier jump? Well, it's from root to root, so from 0 to 46, and that's in feet, so 46 feet. What is the skier's maximum height, jumper's maximum height? That's the y value of the vertex, so 12.167 feet. All right, 17. The arch of the Gateshead Millennium Bridge forms a parabola with the equation right here, where x is the horizontal distance in meters from the arch's left end, and y is the distance in meters from the base of the arch. Arc. Okay, so we look at the form, and we can tell it's vertex because it's in parentheses squared. So vertex opposite, so this is HK, so opposite of that is 52.5, comma 45. Axis of symmetry, x equals h, so x equals 52.5. What is the width of the arch? So it's negative, so we're just going to draw a rough sketch. We know it's facing down because it's negative. This is the vertex right here, 52.5, comma 45, and it tells us x is the horizontal distance. So that means the distance from this point to the middle is 52.5, and we know if the bridge continues on that same path, it'll go another 52.5. which means the total would be 105. So what is the width of the arch? It is 105 meters. All right, number 18, stone is dropped. So this is really just being able to read a graph here. How long is the stone in the air? Well, from 0 to about 5.6. So I read this as an interval. I don't include 5.6 because it touches the ground there. At 3.5 seconds there, how far is the stone above the ground? So 3.5 right here, 300 feet. And when is the stone 400 feet above the ground? So this one's a weird question too, because I read this as an interval. So when is it 400 feet above the ground? Well, from 0 to 2.5 seconds. 0 included, and I include that because it is definitely above the ground. Now, if you just put 2.5 seconds, I would understand you meant there was 2.5 seconds, and here if you put 5.6, I would understand that as well. Right on to the back. All right, number 19, here's another function here. So the function right here models a jump of a red kangaroo where x is the horizontal distance in feet and y is the corresponding height in feet. So once again, it's in parentheses squared, so that's vertex form. So opposite of that is h, and that is k, so 14, 6. What is the kangaroo's maximum height? Well, it's 6. Let's look at the units, feet. And well, how long is the kangaroo's jump? So we know right here, he's jumped 14 feet. If he continues on the path, he'll go another 14 feet, and we add those together, he has gone a total distance of 28 feet. All right, last one, number 20. Although a football field appears to be flat, its surface is actually shaped like a parabola so that rain runs off to both sides. The cross-section of a field with synthetic turf can be modeled by this equation here. Here we see two x's, so we automatically know it's intercept form. So our intercepts are just this x right here is 0, 0. And when we solve this one, we get 160, 0. What is the axis of symmetry? So P plus Q divided by 2. So x is equal to 80. What is a vertex? So 80, we plug this into the equation. So negative 0.33. All right, plug it into our calculator here. And I get 1.472. Let's just make sure I did this right. So 80, negative 0.00023. Ah, I forgot a 4. There we go. So let's fix that real quick. Where is it? And there we go. 1.4976, so 1.498. All right, so what is the field's width? Well, it's from 0 to 160, so we're going to assume it's 160, which is right. And they don't give us the units. I know it's supposed to be feet or maybe yards, so let's just say units. And what is the maximum height? Well, the y value of the vertex, the maximum height, so 1.498 units. And there's a review.